Hello everybody, so we're going to talk about Ritty, an obsolete mode. I'll answer that question for you and tell you what the answer is. You could put an antique mode because Ritty's been around for over 100 years now. The first Ritty over radio was back in the early 1900s. So let's talk a little bit about what it is before we start. What have I done? Press the wrong button. Whistle stop to. So what is Ritty? There we go. Oh, all finished. So what is Ritty? It's the first digital mode. After CW, it's the first digital mode. It was used exclusively, well, not exclusively, but it's used commercially in the 30s and 40s. It's basically two tones that are sent, two audio tones-ish, that are sent with a certain distance between them. In the early days, it was quite important to know what the two tones were. Today, with today's software that you use for decoding, it doesn't really matter, and I'll show you why. You basically have one tone is called a mark, is used a mark, and one is a space. So that's like ones and noughts, basically. You look at it as ones and noughts. The old terminology was mark and space. Amateur use today, the amateurs use basically two shifts. They use 45.5 board shift most of the time. Sorry, 45.5 board with a shift of 170. So that's the two tones are 170 hertz apart at a speed of 45.5. There is the occasional bar take competition, which is basically uses 75 board, so it's a bit quicker, or quite a bit quicker. And there's been a number of spin-offs from Ritty. So basically after the war, everybody was using it commercially. People tried to get up the performance and they came up with Sitor and Amtor. Sitor and Amtor are basically a way of, in Ritty you just send the message, you broadcast it out. In Sitor and Amtor, basically you send a bit of the message, the other end says, yes, I've got it, send me the next bit. Backwards and forwards, big handshake. And then there's Pactor, which is basically putting packet data over Amtor. So that's basically what it is. And which one do I press? That's the one, right. So today there's little commercial or military traffic. If you're around in the 50s, 60s and 70s, you could have put your decoder on and you could have decoded news broadcasts from places like Iran, China, Prague, very, very easily. Today there's absolutely nothing. You will see one or two reports where people say, I've heard this, I've heard that. I've tried listening on those frequencies and never heard a damn thing. So I'm not sure they're still there. But if you want to hear some commercial stuff, the maritime weather information is still around. There's the German station, and this is actually this is what it calls, and these are the frequencies. The 4583 frequency, that's very strong. I was listening to that last night, it comes booming in. If we have time at the end, I'll show you a log from it. There are other ones worldwide. If you do pick up, and I'm not sure how many of them are still going, there's one in Halifax, there's one in Hawaii, there's one in Mobile down in the Gulf, which is good to listen to in the hurricane season. Well, used to be good to listen to in the hurricane season. I'm not sure if it's still going. There's some out in Australia and in the Middle East and Far East. So basically, if you tune through the bands, all you're going to hear today on Ritty, apart from the amateur stuff, is basically the marine weather. And it's not an easy to understand language. You occasionally get a weather forecast. A lot of the time you'll see groups of 5-letter numbers, sysop numbers, and I'll explain those at the end what they do. On the amateur side of things, since FT4, FT8's been around, I think the Ritty activity's just about died and got off the cliff. You can occasionally hear something, but if it's a contest weekend, the bands are heaving with it. You get in the big American contests, the CQDX contests, CQWPX and WWX contests, you get about 3,500 logs going. So that's the number of logs worldwide. There's other people that don't bother to put the logs in who are taking part. So there's a lot of activity. So if you want to hear Ritty on a weekend, probably between 12 o'clock on Saturday, 12 o'clock on Sunday is probably the best time to listen, because some of those contests are 24-hour, but you'll see it in the bands. Most weekends it's on. If you listen this weekend, you'll hear the Ukrainian Ritty contest. And even though they're Ukrainian, or there was one the other weekend that was Mexican, you hear activity in Europe because the European guys are always trying to talk to the Mexicans and the Mexicans want to talk to the Europeans. So there's a reasonable amount of activity. Right. Let me go through a brief history now of... So actually the answer to the question is a Ritty an obsolete mode? The answer is no, it's a contest mode. It's really where we are today. And I hope I'll show you at the end as to why people use it for contesting, because it's a little bit more exciting than FT8, FT4, where you just press a button, even though it's only just move a mouse, but we'll talk about that. So if you look at the history of Ritty, the first Ritty machines, if you can call a Ritty machine, so if you define a Ritty machine as basically a machine that sits there and shows you a message or tries to print a message out over some wires. The first Ritty machines in that definition were around in the 1750s. They were basically machines that they were machines that used electrostatics. They didn't use electricity as we know it because the battery hadn't been invented then. They were basically using pith balls or gold leaf, and basically they talk about the distance they went by the number of rooms. My machine will do 2 rooms, and the other guy said, mine will do 3, or mine will do 1. And it was basically a number of wires collecting these little pith balls or gold leaves and making them move between various rooms. So that was the first machines. They were very much a novelty that the gentlemen scientists of that time showed their friends. You then move forward to the beginning of the 1800s and you get the first batteries around in about 1800 with Voltaire, and the galvanometers are invented. Your galvanometers are basically moving core meters, for anybody that doesn't remember those. They basically had those type of machines, and if you look up the top here, this is a Cook Wheatstone machine, and basically what you have across the, you probably can't see it, but across the middle here, you can just about see some arrows and a keyboard. And you press a button, and the machine at the other end lines these arrows up to point to a number up this, sorry, a letter up this triangle or down in this triangle. So by pressing the keys, you could actually send numbers. Very slow, very difficult to read. It was the Cook Wheatstone machines were used on the railways in the UK from about the bit of the 1930s. They had multiple wires. Some of them had multiple wires. They also had various different codes, but it was that sort of principle. If you look at the first instance of a criminal being caught using a telecom device, it was basically over one of these machines between Paddington and Slough. There was a guy who killed his mistress, tried to depart the country by going to Slough, and actually the Bow Street Runners in must have got him. Then we have Samuel Morse and Albert Bale. I think he was not a good thing from a Ritty point of view, because when he started, he was actually still trying to do whichever all the other inventors of that time were doing, which was actually to come up with a machine that you could send messages from one end to the other. He actually spent about 3 months, Morse did, trying to put together a series of codes against a dictionary so that you could actually have a code go through which would go against a word. He then met Bale, and Bale was a little bit more of a mechanically minded than Morse, and they actually came up with Morse code. The trouble is, from a Ritty point of view, Morse code is horrific because it's variable codes, it's any length, any speed, depending on how you send it. It may not be that well sent as well. So if you were in these days where you were basically talking about machines that had some electric motors in them, had clockwork that actually decode that was quite a big problem. Also, during this time, Morse code was very, very popular. It was rolled out very rapidly across the US, around the world. So if you look by the into the 1880s, you could basically send a message from anywhere in the world to anywhere else that was any part of the civilized world, let's call it that. And this is basically a picture of Morse's Morse code machine. Now the other thing when you look at the the Ritty history is, it's not one person coming down and coming out of the eureka mode. There's lots of people doing a little bit of everything to put stuff together. And then we come to Emile Bordeaux. He's recognised as inventing the 5-bit code. That's not strictly true, because there's a guy called Karl Gauss, who was a famous mathematician and a physicist in Austria. He actually had a messaging system between his observatory up on the mountain and the university that actually used the 5-bit code in the 1830s. So Bordeaux borrowed some of that. But he came up with a time division multiplex system, which is probably the first one in the world. And that was basically clockwork and mechanically driven. And this is one of his machines. And the way this worked is, you had 4 or 5 of these machines. You had 2 hands, right? So 5-bit code, 5 fingers, one hand of these 2, another hand for these 2. You pressed the keys down, you put the actual raw code in, you waited, the central apparatus spun, went round all these machines, picked up all the codes, clicked the keys back up, sent it to the other end, printed it out. You pressed the next letter and the next letter. They had to put the code in. It was used between London and Paris, and the British Post Office at that time did some other work, used it internally in the UK, but never really went anywhere. It was a little bit of an oddity. Then you come to Donald Murray. He really pulled it all together in terms of Ritty. So he said, well, it's pretty silly, you need a keyboard. Now Murray was a journalist. He was born in New Zealand, and he worked on went to Sydney, worked on the Sydney Herald, and he was there and he realised that actually if you needed to send messages between 2 places, printing it out or keying it out was probably not the best way you needed the keyboard. So he did 2 things. He had a keyboard. He also separated putting the code onto tape against sending it. So you could actually, in slow time, type your perforated tape out, and then you could send it through at full speed. He modified the board code. Basically, the reason he said was, basically, I've modified it to save machine wear. What he actually did is he took the code from EML and made sure that commonly used letters caused less punches on the tape. This is fancy way of saying that. But it was a complete system. It basically was, you could type it in, send your perforated tape through the transcender, receive the other end, and it was printed out in letter form. So it was really the first complete system. All this was done over landlines at this time. It wasn't radio, because radio hadn't really been got going then. And then you have Howard Crum. He pulled it all together, because even at this stage, and I'll explain a little bit about it in a minute, it was still a bit of a problem synchronisation, because the synchronisation in Ritty wasn't all there yet. The stop bit part of it wasn't there. And Howard Crum put that together in about 1910. However, it's not quite as simple as that, because there was a German company after the war tried to sue these guys because of a patent infringement, intellectual property on stop bits. The other interesting guy about this guy was, he was the father of a guy called Charles Crum. Now, Charles Crum had a mate called Joy Mort. Now, Charles Crum ran a refrigeration company in the US. Joy Mort, and I think it was a guy, but I'm not 100% sure, actually ran a salt company. In the early 1900s, or just before, around the 1900 mark, they met a guy called Alexander Perney. Now, Alexander Perney said, I can build you a teletype system. And these 2 guys invested in him and set up a little company for him to do that. He got fed up after about a year and went off and did teaching. But Howard Crum was the son of Charles Crum. So he took it over and developed the system further. And that came down to the Crum company, which later came into, which did the early teletypes, and that later became into one of the Western Unions, and Baby Bells and that in the US got absorbed. So when you see the early teletype names, you'll see Crum company come up, and Crum and Klein Smith. And Klein Smith was the people these guys were having the intellectual property problem with. So instead of fighting it out in the courts, they said, we'll come together and form one company and all be nice friends. So they did that. So that's the Crum company. That also went into the, if you see on the teletype stuff, you'll see Teletype of America or Teletype Inc. company. That was basically the Crum company that just moved on. In the UK, you'll hear about Creed. You must have heard of Creed. Yeah. So Creed came about because there was a guy called Jonathan Creed. No, it might not be right. It might be Alexander. I can't remember. It's either Jonathan or Alexander Creed. So he was born in Nova Scotia. He was a CW operator. He started working in Peru and Chile with the machines that were there, and the machines that had to pipe, they used to pre-make the tapes, and making the tapes with the machines at that time was not very straightforward. It was fairly arduous and fairly mechanical. You know, you actually set it up, you banged it down, pulled the tape through, set it up again, banged it down to perforate the tapes that you then used to send the Morse over the landlines. He came back to Glasgow, bought a little house with a garage, and actually started to develop better CW perforators that were actually much more easier to use and less mechanical. He got a lot of business in the UK with the then Post Office and also some of the press agencies in London in Fleet Street, sending to use on their systems. He also started developing the teletype, the teletypes. He actually started sending the first radio teletype information prior to the war over long waves, only across 300-400 yards. Had a big area in London. War broke out. Home Office said to him straight away, take your aerial down. So that all stopped. And his company in the war went on to develop munitions and some of the other apparatus associated with radio. Post-war, he started doing teletypes, and he actually bought up all the patents from Mr. M0IEP. Mr. M0IEP sold his patents, went down to the south of France and wrote philosophy books. Well, that was his excuse. But so that's where the Creed company comes from, and then Creed eventually went into IT&T around, I think, the 1930s. So that's sort of a brief history. I hope that's clear. So let's just go through the. So that previous slide was up to about the mid-1920s. You had the two companies. There were, like I said, there were short Ritty links prior to World War I. They were on long wave frequencies. Radio hadn't really caught up with it then. You then look after the war, and during the war, as I understand it, there was a lot of development on radio, air to ground, how you send radio messages over long distances. So basically, after the war, that went into the commercial area. So we had the first air to ground in 1922. That was between a US Air Force base. Long distance links were developed in the 1920s. They started off using on-off keying, so they didn't do any tones. So the mark and the space, if the signal was there, it was a mark. If there's no signal there, it was a space. Didn't work very well. So they quickly realised they had to go to another method, and they went to basically FSK. And FSK is where you change the frequency of the carrier to as if it's an audio tone. I'll explain a little bit about that in a minute. So commercial routes from the 1930s. There were basically commercial routes were across America, started to go across the world depending on propagation. World War II came along, rapid growth in it. You know, all the press people, all the press officers, press liaison officers had them in with the army. You could literally send, your sensor could sign off your report in the Far East or in Europe. It could be back on your operator's desk within 10, 15, 20 minutes. Because they basically used Ritty over the air and using FSK. After the war, basically people looked at how they could customise it. If you're a Russian or if you're I think it's Greek, you might want to send Russian alphabet or Greek alphabet or Arabic alphabet. So they customised the code to do that. They looked at tones and shifts. If you didn't want anybody to listen into you, in those days, you couldn't just click something on a computer and say, I don't want to be 120 hertz shift. I want to be 400 or 385. You had to hard code it into your devices with basically with filters, two audio filters, one on the two tones that you wanted to detect and the separation between them. So it was a reasonable way of trying to give you a level of security. And then also people played around with the protocol and the logic of it, just to make it difficult to read. And that basically went on till you came into the 70s and into the 80s. The internet came along and satellites, and it's died apart from the marine stuff. So that's the commercial stuff.
I was still using it.
What the pictures?
Oh, sorry, yes. So this is one of the early machines, yeah. Yeah, I mean, basically, when Murray did it, he was a journalist, so he's familiar with the typewriters that way. He basically took those and put those together to make a Ritty system. And this doesn't show up very well, but this is I think these are Creed 75s during the war with the ladies operating them.
That's not a collection of
No. No. If it is, I don't really. I wouldn't say. I don't know such a thing. I actually had one of these machines when I was a kid, and I had it about 3 weeks, and my parents decided I couldn't have it in the house, and then I put it in the shed, and then the neighbours complained, so I had to get rid of it. But mind you, I had to make it work, so I might not have made it work properly.
made a lot of noise.
They were very, very heavy, and they made a lot of noise. A lot of noise. You couldn't hear yourself speak.
Yeah, they had covers you could put over. They still weren't that silent.
Well, they weren't there. In a room with them, you couldn't. The clatter was just out of this world. It was just.
Go back a couple of decades, you get the football results on a Saturday afternoon on the television. You hear those clattering away over the top of the voice of the commentators.
Yeah.
But they were still using Ritty air to ground in the 80s and 90s when I was in the Air Force, because I used to use it all the time to send stuff to the Nimrod aircraft.
But it's very difficult to actually find out when it died out. It wasn't like different services used it for different lengths of time.
Yeah, no, it used to break through on lots of wood.
Oh yeah. I mean, when I was a lad and listening to it, you just got so much. You could tune up and down the band, and it was full of it. Oh God. Right, amateur. The history of Ritty and amateurs. So you notice 1946 is when it first started. There's a very good reason for that. Even though there was amateurs around prior to that, the companies that made the teletype equipment, the Ritty equipment, actually were hanging on to it. So if you had a piece of equipment from them, when you'd finished with it, you had to give it back to them. So there was none around for the amateurs to actually pick up on the second-hand market and actually use. Secondly, these were mechanically very, very complicated machines, so trying to build one was just about impossible. You know, there was, I don't think you could do it. If you could do it, it'd take you years. So basically, in 1946, the amateurs in New York had a contact with the New York police, and the New York police were upgrading their Ritty system. And the amateurs got hold of their old teletypes that they were actually using on the understanding that they would only use them for amateur use and wouldn't put them to any commercial use. And that's when basically the first amateur Ritty contacts were made. There was actually 2 done during that year. Basically, there was an HF. It was make and break, and the reason for that was the licensing at that time did not allow you to do FSK. That came later. And on 2 meters, they did it with AFSK, FM and ASSK. So that was the first one. Then basically in California was sort of the hotbed of Ritty in the early days. Basically, they actually made some agreements with the providers of the Ritty equipment so they could actually get the second-hand stuff. And you get to the situation when you get to 1949 where you basically get the first trans-American contact. Now, if you were in those days and you wanted to do Ritty, it wasn't a simple task. Like today, it takes you about 10, 15, 20 minutes to set it up. In these days, it was a big task because the first thing you had to do was get your hand on a machine. The chances are the machine wasn't working. There was quite a lot of support groups around that actually had all the details of the manuals and all that, but you still had to make it work. You then had to work out how you were actually going to transmit your Ritty machine. So you had to build a terminal unit that changed basically the the mark and the space that were coming out of the Ritty machine, and that was voltages up to plus 160, minus 160 volts. Some were 80, some were less than that, depending on the manufacturer. You then had to, at the other end, you then had to decode that, do the reverse, get to drive your Ritty machine. So that was quite a big problem for the amateurs at that time. So it took quite a lot of work to actually set it up. And if you read online, there's the Ritty journals from this time. So if you type in Ritty journal, you can pick all the journals up from about 1950 all the way through to 2003 when they stopped. And that tells you exactly all the issues they'd done, how to build and look at and repair these Ritty sets. They had simple issues like they didn't seem to understand about cycles. You know, the fact that actually when you did CW, it was pretty on and off. You probably didn't send it for too many minutes. You waited, your transmitter called off, you went off again. With Ritty sending it, particularly if you were typing, your transmitter could be up for several minutes. So there's stories of they're actually burning their radios out. Modified CW transmitters, actually, the duty cycle for Ritty was too high, so they burnt out. The other issue they had was, how do you do FSK, right? So initially, before the FCC allowed it in 1953, basically, they were just doing on-off. So basically, they had a relay, basically placed the CW key, the relay, clicked it on and off. So very straightforward. When you're allowed to do, they realised they have to do FSK because that's the only way you get performance and distance. They came up to other problems. It's very easy to do FSK on one band if your VFO is the same frequency as you're transmitting. Right? If you've got a transmitter where you're using some harmonic of the VFO, you know from your simple theory, everything multiplies. So if you actually do a shift of, say, 170 down on your VFO, the second harmonic is twice or three times that as you go up. So it's a little bit tricky. So on a single band, it was relatively straightforward to build a VFO, and basically the initial designs used basically a relay and a capacitor. You switch the capacity in, it changed the frequency. It got a bit more complicated reasonably quickly when they used diodes to actually do diode switching of the capacitor in. So that gave you the FSK. So 1953, FCC allowed FSK. Had to be 850 hertz shift, and only allowed it on those bands. 1953 as well, you know, 60 word split. So that's basically, I didn't mention on the commercial stuff, it was reckoned that the Ritty operators could send 2.5 times faster than the CW people. So you can see why the commercial guys wanted to go down that route. End of 53, there was the first Ritty contest. Now, the organisers were very upset about this, because in the US, there were about 400 operators of Ritty. So they ran this competition because everybody said, oh, we want to take part. And they only got 29 entries. So they were not pleased. If you read the article, there's a little article about it. 1956, you notice I'm not talking about Britain. At this time, this was all done in America and American areas of influence. So where South America, sometimes out in the Pacific, where Americans have been, there was a lot of Ritty activity. In Europe, you could get Ritty machines at this time, but they were very, very expensive. In the UK, that was just, people just couldn't afford it. So in 1956, the FCC allowed FSK with the 900 hertz or less shift. So that allowed you to drop the shift down. And having a wide shift is not necessarily a good thing, because basically the propagation, when you start having a wide shift on the two different tones, can vary a little bit. So you get fades and shifts and strange effects. It's interesting, if you read some of those articles, around that time, some of the articles, the CW guys are saying, oh, Ritty will kill amateur radio. And we've heard that before. Recently, yeah. So that brings us on to 1956 in the UK. So BARTAG, which is the British Amateur Radio Teledata Group, was formed. So they had a problem with getting Ritty machines to use. So Miraculously, the General Post Office, I think it was then, basically said to these guys, we've got 25 machines you can have. So somebody, you know, somebody was influenced, who must be in the know. That allowed the first Ritty contest in the UK. Basically, that was around Suffolk and Norfolk. About this time as well, it was realised that actually the Ritty standard in the US, what the Ritty was doing, the Ritty standard in Europe were all slightly different. The UK one was around the 50 baud rate. The US one was around about 45.5. So basically the UK guys and some of the European guys couldn't talk to the US, and the US couldn't talk to the UK. And of course it was in the machine, so it was a little bit tricky to change it. What was actually worked out was the US machines basically used a synchronous motor, so you basically couldn't change the speed of the US machines. The UK machines, particularly all the Creed machines, had a little governor. You know the butterfly governors that spin round? So they had one of these little governors that set the speed of it. And what was worked out, which was really quite clever, was you actually took your Creed, your machine, you've got the little butterfly thing that spun round, you put a light by it, a filament light by it, and you could synchronise it to the 50 hertz of the mains. And then there was a little screw you twiddled, and if you backed that off a number of turns, I think it was something like 7.5 turns, that set the speed at 45.5. So it was an easy fix, and then everybody could work together. You then get into 1969, and basically that's the first Worked All Continents Awards. And then 1971, first 100, Worked All Continents 100. Now this guy, right, he did it. Everybody said he did it, but he didn't get his QSL cards verified.
Guadeloupe, isn't it?
Is it Guadeloupe? Yeah. And then from the 70s onwards, basically what happened was transistors came in. You had terminal units, which were basically either initially logic driven, but then with microprocessors. So you basically plugged your PC or your terminal into a terminal unit, which could decode it. And then, as you know today, it's basically you plug your computer in. So that's really the amateur history in a nutshell. But it's how these guys initially got it going. It was a hell of a task. What am I doing? Right, let's talk a little bit about the code. So if you remember, I told you saw the Emil Bardot's machine. 5 fingers, 2 on each hand. 1 hand, 2 fingers. 1 hand, so 3 fingers. So this is what you typed in. And as you can notice, there is only 32. It's a 32 bits or 32 codes. So basically, you have to have some that have 2 meanings. So you have to have a shift key. So when you send, you can, if you, for example, if you send, let's pick a Q. Where's the Q? Yeah. So if you send a Q, it would, well, start your barrel. Let's pick a J. A J could either be a J or a 6. So to send, normally it would be in letter mode. So you'd send letters. If you wanted to send a number, you'd then have to send a figure shift. So that would then put it into figures, which is the other column. So this is what you typed in. This is what the machine actually sent down the line. And then this one is basically what Murray came up with optimising the code. You can see the ones at the top, there's slightly less dots. And he also came up with lines and spaces as well. And then just to show you how, so this is the Murray code, beginning of the century, 1900s. This is what was actually in the ITA 2 code specification in 1993, and you can see it's almost identical. So no real change. It really should be called the Murray code. So let's just quickly talk about, we're going to talk about diddling in a minute at the end of this, so you can look forward to that. So the board code is very simple. It's basically mark, space. So you send the bits, 5 bits. If it's a mark, or a hole, you send a mark. So Y can either be a Y or a 6. So this is an R or a B. So this is what is sent today. So basically you have a start bit, the 5 bits of the code, and a stop bit. So you can imagine before the stop bit was invented, the only bit you had to synchronise on was this. So that meant that synchronisation was quite a problem on the early machines. Because you have this, it makes synchronisation much better, not perfect. Now this is where diddling comes in. So when you first send a message, particularly with amateurs over the link, you're probably going to lose the first 1 or 2 characters that you send because you've got the other end's got to synchronise its decoder with you. Even today, and when I show the demonstration later, you might even see 1 or 2 first characters disappear. It takes a number of characters for this to sync. If it's a good link, it'll be 1 or 2 characters. If it's a bad one, it could be 3, 4 or 5. So diddling is where you send spaces or full stops at the front of your message to make sure that the other end's decoder is synchronised. Right, just to clarify the shifts, basically, if I'm sending my call sign in Ritty, you send an M, you send the figure shift, you send a 0, you send the letter shift, then you send the I, the E and the P. All right? So actually, you send 7 characters to send, have I done that right one? So yeah, 7 characters instead of 5. Yeah, and basically once it's in one or the other, it stays there until you tend it to go out. So you can see if you lose one of these, it can be a little bit of a problem. But I'm going to show you a little trick in a minute. Sorry? So if you lose those, you end up with something like this. So you sent the signal port, you end up with this. Right. So if you know what is coming, you can probably, but it's a very easy trick. If you have a keyboard, guess what? Well, 1 is a Q, 2 is a W.
Oh, yes.
Right, so we had T00599. All right, so very easy. Now a little bit of technical theory. Right, FSK versus AFSK. There's the 2 methods that are used. So originally FSK. So FSK is where you take the carrier frequency and you move it from the shift that you're sending. So, for example, if you're sending a tone of 212125 and 212195, basically you're shifting the frequency to 2125 and then to 2195. When you use AFSK, you have it in, basically today it's single sideband, and all you're doing is you're putting those 2 tones into the radio and it's sending those 2 tones. There's no difference in performance. Right? They look exactly the same. You'll see people say, oh well, FSK is better, and then you look at the arguments, they'll say, well, FSK is better because people don't set up AFSK properly. And then you look at AFSK people and they say, well, AFSK is better because we set ours up properly and FSK people don't. It's more hard to set these up properly because you get clicks and all those sort of things. So there's really no difference. But if you're a Ritty fundamentalist, you will probably stick with this. And by the way, this is not easy to set up. You have to do various leads. You know, it's a bit of a pain. Right, so this is really just to explain what I've just said. So AFSK, single sideband, this is lower sideband, upper sideband is identical the other way around up here, okay, just reversed. So here's your carrier, you basically send for AFSK, you send 2 audio tones, 1 for a mark, 1 for a space. Right, very simple, and you can hear those. If you're doing FFSK, this is where your carrier frequency is, you actually move the carrier to those 2 frequencies. straightforward. Everybody understand? Yep.
Keep doing it.
Sorry?
Keep doing it.
Yeah, so that's why Afsk is so much simple. So if you then look at the other end where you're receiving it, actually, they don't look any different. So basically the same. So what do you need to run Ritty today? Well, you need a radio, you need a sound card, either in your radio or in your PC, and maybe an interface as well for the keying, depending upon your radio, a computer and some software. You can set it up in 15 minutes. If you're doing WSJT/X or FT8, FT4, this is really simple. It's just you can do it, no trouble at all. And just to give you an idea of some of the software, there is, I spelt it wrong. There's hundreds of software packages out there. This is just a few. These two here are probably supposedly the best decoding Ritty software. Two-tone only works with MM1, M1, MM. Ritty you can use as standalone. FL-Digi, that's really the Swiss Army knife for digital modes. If you use that, it will do all the digital modes you'd like to come across. And it has a couple of neat tricks as well. MITI, that comes, it's been around a long time. It's supposedly very easy to set up. It comes out of the box. I've used it a couple of times, and my own opinion is it's not that good. But that's my opinion, so I might not have set it up properly.
That gets used sometimes by DX because you've got an MMTY vary, which will do multiple.
Yeah. This one is this mix W is used by the Eastern guys. Yeah, Russian ones. Wim Wardler's part of the slab sweep. This is supposed to be Digital Master. I didn't realise I had a spelling mistake. It's part of the Ham Radio Deluxe suite. Works quite well. I've used that. And then really, if you've got an old computer, you want to run it under DOS, you can still get HamCom 3.1. It's downloadable. Right, I'm now going to show you a demo. So this should be good. Sorry?
Fingers crossed.
Yeah. One. Right. Sorry? Oh yeah, there we go. Right. Right, so this is Ritty. It's receive only, doesn't do transmit. It's basically for amateur Ritty. It is the only one that's got some form of, what's the word I want? Help in detecting the Ritty signal. It's got some Bayesian statistical analysis in it. And what it's doing is it's looking at the signal that's coming in at the bit level and deciding whether the probability of that bit being right or wrong. So that's sort of error correction. Now the thing about all of these is it's not like you get garbage on one and you get a perfect signal on the other. What you end up with is you get pretty ropey signal on one and a little bit more of a ropey signal on another. And in that ropey signal on the other one, you can actually understand something. So it's not like plug it in, one works very well, one works pretty badly. Of those ones, one works a little bit better. And people will discuss with you and have their favourites. So basically what Ritty does is, it's a receive only, it's very easy to set up. You just basically plug it in. The only setup controls you have are these at the top here. Let's just use that. So basically all you have to do is set the sound card up the top here, and basically on that one set USB or up USB. Now today most people use USB all the way through the band on amateur work. Have we got to disagree? No? No. Most people use USB, so USB is the one used. If they don't, then there is a slight trick to go around it. Basically, you have the signal coming here. So Ritty just basically looks at the signal in the bandwidth. It picks one, decodes it. When that one goes away, it finds another one, decodes that one for you. And as you can see, it's calling out. Do you want to hear it as well? That's the sound, Ritty. You all must have heard that. All right. You've got a signal to noise meter up here, and it's just telling you there's a CQ going on. Very simple. I use this one quite a lot as a second decoder because it sometimes throws up a little bit more information than the other ones. So that's Ritty. Now, where is it? Right, this is FL-Digi. So let me just explain what's on the keyboard. So this little bit up here, there's a cat controller to the radio, all right, so this is talking to the radio. This basically tells you the frequency of the radio. These are the boxes that you'll fill in to log your contact and also to help you with the macros, and I'll show you about macros in a minute. This is what you're receiving. Basically on the you actually select down the bottom here. You see can you see the two lines?
Yes.
And the things going down. That's basically me selecting the Ritty signal coming in on the waterfall. These are your macros. Right, that's the expanded set. Let me just shut those down so that you see there's also, you can also have it the smaller set down the bottom here. This is a signal. It looks at all the signals across the whole of the audio band in your waterfall. So if you've got 3 or 4 signals here, they may appear here, you know, as going across. And then you just click on one of them, and that'll tune it in for you. What else? This is where you type in, if you want to type in. These are your macros, and this is the waterfall. You all know about waterfalls, yeah? Yep. So if you want to look at, for example, there's a contact being called there. So basically, you want to reply to it. You click on it, and you get this menu up. Call, name, QTH. And what this does is, you click on call, and as you can see, it's put call in the top box. So that's all you know about that guy at the moment. He's calling, you want to call him back. You then go answer. God, I hope this works. He's going to stop CQing. You've sent your call back to him with the macro. So all you've had to do is click on the call sign. It goes in the top there. The macro that's already in answers it. The guy at the other end then says, calls you back. No, we'll just let this finish. So this is basically the sort of message you would expect to come back the first time. You know, different people have different ones, but something along these lines. So it's like, going to stop? Yes. He says, hi, old man. In a lot of the Ritty programs, if you don't put the person's name in, it fills it in with default as old man. Not old lady or old person. It comes in as old man. It normally comes back with the signal strength. Now 599 you'll recognise. You also get 5NN. Oh, sorry? Yeah, so, you know, I find it annoying, but people do it. It'll probably tell you his name, his location and where he is. So what you can do is then you go along here and you say, well, okay, so his name is Viv, so I'll put Viv in. His location is Swindon. His QTH is Swindon. So I'll put that up the top. And he gave me 599. So there we go. So then you go back and you send him a QSO. Making sense? Yeah. So then you go back with and I'll show you how to alter the macros next. So then you go back to him with a nice message. His name's gone in. His signature name is Viv. Oh, Viv at both ends, haven't I? Good talking to myself, yeah. All right. The only other thing is you'll see back to you as well. It means you go back to you. So B to you is back to you, meaning back to you or over. And then you'll have a jolly little chat. And then when he's finished, you'll see something like, thank you for the QSO, 73s. And then you'll see his call sign, and then he'll say silent key, silent key. And when you see that, that normally means doesn't want to talk to you anymore. End of it. So that's a simple QSO, how it works. So how do you do the macros? So basically, which one shall we do? We'll just do the QSO one. Yeah, click on it. You right click on it. Right, so I'll just make it big so you can all see it. Down here is a list of all these things you can add in. Now when you start FLDigi for the first time, there's a lot of menus you have to fill in, like your name, your location, your radio equipment, your aerials, all that type of thing. I recommend you do that because all these come through. So what you do is, I don't know if I've got an aerial in. I can do so if I want to put, for example, in here, I want to put, before I put my QTH, I want to put the version of FLDigi I'm doing. I highlight it, press the little arrow, and in it goes. Right, and you can say it is a good version. Right, you then apply it and close it, and now when you send it, you're going to send the message. You just put it in. It's a good version. Right, very straightforward, very easy. All right. Any questions? No? Right. Hope that makes sense. So that's really all there is to doing a QSO. All right. If you're lucky to find one. Now, FLDigi has one other little trick. Up the top here, up here, is a RxID. Right. So this is the Reed Solomon, which automatically selects modes. Doesn't work on Ritty, doesn't work on PSK. But it works on all these exotic digital modes. So if you're tuning around, I've got to hope this works, and somebody is sending something in, let's say he's sending in Cortesa 825, and I send it, you can see this is switched to the mode. So if you do want to play around with digital modes and you want to send in more exotic ones, you have to tick TX ID. That sends it, but it's worth having that ticked all the time because you may just pick up a contact. And just to show you the modes you have in so these are all the different modes. Well, each one of these has got a loading. So if you go down them, that's the Contessa ones, Domino, FSK, Alfia. So you've got plenty of pick. Yeah. So if you want these exotic modes, Saturday mornings, the Russian WWD Digital Club normally has something going on Saturday mornings on 20 meters. You can hear them. So you can hear them there. I forgot to mention, if you want to hear Ritty contest in the week, Friday morning at 0045 Zulu, or I can't remember if it's 0045 or 0145 Zulu. The Americans have a Ritty QSO stroke contest party. I don't know. I think it's on 20, but I'm not 100% sure. And let me just show you configuring this, just to take you through. So the configuration of FLDG. So you basically go to configure up the top here, configure, and then configure dialog. You basically have a whole load of, like I said, these are all the things you want to fill in, because when you do the macros, you can just use them. What else? Rig control. Come on. Basically, I use hamlib, but whatever you're using for WSJT or whatever, you should use. If you're not using anything, hamlib is probably the way to go. But you can configure a load of stuff. And very quickly, let me just show you how you configure it for the marine weather forecasts. So you go to the op mode, you go to Ritty, you go to custom. Sorry? And of course, I've got the wrong one. So basically, it's custom shift of 450 with a speed of 50 baud, I think it was. That's all you do. You have to go into TX, and that will then do the bigger. That hasn't happened. Save. What have I done? Oh, one was. Oh, carrier shift. I need to go down here to custom. That's what I was doing wrong. Save and close. And as you can see, this has expanded now to 450. Yep. So this basically simple QSOs. If you want to do contesting, you can use FLDigi. It is a little bit more complicated. So let me just quickly change something here. Back to Ritty. I think that's right. There we go. Put this back to. But if you see the contest, basically what happens is you'll see something with CQ test. So if you don't see test, or you don't see a call sign with test after it, it probably is not a contest station. So it's looking for normal QSO. If you see test, you'll sometimes see call sign with a test after it. You'll see a call that goes out like this. Okay. If you answer him, so if you're doing a contest, you don't put your call sign back in there, his call sign back in there when you answer him. You just go your three call signs. He knows his call sign. He doesn't know yours, so it's just a way. Complete waste of time. So basically, you send basically that. I'll show that in a bit more detail in a minute. And then he'll send you something like, yeah, will he? Oh, that's not, hang on. Let me just do that properly. So he'll send you probably very much along these lines, which is basically a signal report and a serial number. He'll expect back from you a signal report and a serial number. You can always send the same one back, but if you're going to enter, make sure you enter several, because adjudicators tend to don't worry about duplicates, but if they just see one, they sometimes delete them. So if they see several, you don't. And by the way, you don't have to put the log in. You just answer them. Just send a serial number back. Yes. Yeah. And then basically you said, so I'm just not going to show you this in FLDigi because it's a bit of a pain. Oh, I know what I've done. Let me show you how this is done in M1MM. M1Digi would do it, but you have to, if you get the latest version, it has got a contest functionality in it where it'll increment the serial numbers for you. You just put the micros in. Right, M1MM. So you either love this or hate this program. All right. It's probably one of the very frustrating program to use. It basically completely automates your contest. It's a little bit tricky to set up. It's probably used by the majority of the contesters.
Certainly inside London and CW.
Yeah.
And because of this link that you're going to show, Rity as well.
Yeah, I mean, basically, basically any mode that FLDigi will do, this you can automate through this. It'll also do WSJT as well. So you can actually use, if you go into an FT8 or FT4 contest, you can use this. So what you basically have is you have your entry window. So you put your call sign, what you send as your signal report, what you receive as a signal report, what you send him, what he sends you. Now, everybody sends 599. So these two are always 599. Sorry?
Come again?
Again. All right, so everybody sends 599. So the only thing you have to worry about is what goes in that box and what goes in that box.
I'll just modify that. Everybody sends 599 on HF. VHF, they don't necessarily.
That's true.
Yeah.
Yes. No, on VHF they do send.
Yeah. I normally send any one of three, sort of 5, 5, 3, 5, 5, 5, 7. Or 5,
Yes.
So now it sounds.
It just depends how creative I'm feeling actually as to what number I put in the middle. Unless it's a good signal. So this is basically your log. You can see where I've logged the calls previously. Let me just delete those because they'll come up as duplicates. Oh dear, come on. These are in there. Right, so let's start the whole process again. So basically, you put your little lines on the signal. In a contest, this will be full of them. They'll be interlinked as well. If they're interlinked, probably not a good idea to try and decode them. Also, if you get two very strong ones close together, Ritty is a very dirty signal, right? It's like two peaks, two volcanoes very close together. You get a long tail with them. So don't be surprised if you get two very strong ones close together that you can't work them. So basically you get the test message. You take your mouse, You go over here. Oh, that's not right. You click on it. Goes into your box. Those boxes are all filled in. Yeah, I mean, you can use function keys. I use the mouse, right? So it's basically filled it in, ready to go back. You then call him back. So here's the call going back. Now in M1MM, you get various colours. So red is one you should work straight away. A multiplier. A blue, a green is another good one. Go work it. Red, very good because it's another continent, I think.
Well, it can't be too much.
Yeah. A blue is basically, you've worked that country before, it's just a culture, just a QSO. If it's grey, it means a duplicate. Don't bother. But mind you, I always work duplicates. If they call me, I always work them. Yeah, just to make 100% sure. So he's called you, he will then send you back. He will send you back. Oh, I haven't done it right. I haven't done it right. What have I done wrong? Oh, I know. He's not in the contest. There we go. I didn't. Too many machines to work. So he'll send you back your call sign 590. Yep. Right. So you take your little mouse and you click on exchange. Right. So you're sending him back his exchange, your number back to him. In the meantime, you also click on 01. So that fills in, while that's going out, it fills in what he sent you. Yep. And then you hit log, and that logs it. All done. And he will then send you back a. Oh, there we go. No diddling. Look, I've lost the first character. He'll send you that. Thank you very much. QRZ for the next person. So when you go back to him, your first call, don't put his call sign, then your call sign. When you do your exchange, don't put your name. Hi, this is Joe. Nice to meet you. Right. All he's interested in is that number. All right. No. Now, if he comes back to you and says again, so he'll say again, because he didn't receive your message, right? Don't send back the same message again. What you need to send back is what I call the blaster message. Basically, you send 599 because you have to send that as you exchange in your message. You then just send the number a number of times, and it always works. I mean, I can't guarantee it. So, but people who send you, it's really annoying when they send you the same message again, because they might only have the number in twice. So if you get this another time, you get 4 different numbers because of the corruption in the messages. You don't know where you are. This almost works.
It happens the same inside, man. Happened the other night, somebody said, just your number again, and the bloke gave it, oh, bloody right.
Yeah. What else? Let me just show you how the... so setting up M1MM is a little bit tricky. I won't go into that tonight, but a couple of the tricks. So if you're receiving the message here, so say it's a very noisy signal, right? If you hit a line, it moves it into the middle of the band, right? Good thing, because what you've done on your radio is you've set one filter up, your first filter up to be wide, your second filter to be narrow. You then go over to your radio thing over here, hit wide, hit narrow, so it brings it in. And then you go back the other way, it takes it back again. And
That makes a big difference if you've got a crowded band.
I mean, I basically, when it's a competition, I don't touch the radio to move up the band. All I do to move up the band is do Go down the bottom, a line. Down the bottom, a line. And I know that then anything from there upwards is new. So I never touch the radio. Just walk your way up. And depending on how crowded the band is, you set the first filter up. You know, it's probably mine's never more than about 1.5k wide. Sometimes it's as little as 800. This will work for PSK. I think the PSK competition is exactly the same. I've covered diddly. I think I've covered everything. Let me just show you. This is any more questions on this before I show you what the commercial maritime stuff looks like.
Just a comment, maybe. Green signal fence with a white bar on it. That's a squelch control on the bottom line. It's a gotcha the first time you try and run this.
Oh, this one here, yes? Yeah, this one here.
You get noise all over the place.
Yeah, I mean, this was very noise-free. What you'll normally get is you'll get a load of garbage with the message in the middle of it and then another load of garbage, because you need to have this squelch setting fairly low down the bottom. Really just a fraction up from the thing, because basically the RTTY signals, if you have this set too low, you just don't hear them. Oh, actually, there's one thing I haven't covered. Let me just bring that back up again. Which is two things I haven't covered. There's a little button here called automatic frequency control. What this does is that still going? Come on, where's the signal? Oh, I know what I've done. I moved off the signal. So just bring that in the middle. So what that automatic frequency control does, it tunes it in for you. So if I can have it just off, oh, it's not far enough. Hopefully that will bring it in. Too far. If you're very near, it basically tunes you in. Now the other thing you can do with M1MM is you can have multiple decoders running at the same time. So you just enable the touch windows, and then, because I haven't shown you M1 two-tone, have I? There we go. So this is two-tone. Like I said, it's an add-in for M1MM. It's got a number of filters put into it, so you can, for flutter, fading and all that. What about frequency control? It's basically this more classical type of waterfall event, the two tones. It doesn't do any of the clever stuff like Ritty does in terms of, I won't call it imitation error correction, but you know what I mean. But it does do what it sorts out call signs, and it also sorts out numbers a little bit for you as well. So it'll give you a little bit of help in how it separates them out and displays them. The Ritty fundamentalists say this is the best one. All right. Basically, they run with 10 different decoders in their competitions, the real fundamental guys. So basically what they do is they set all these up with all these filters in it. They set Ritty up with some of the filter, just a couple of different settings. They set up I think it's M0IEP as well, So they basically have the 4 in M1MM, then they have another 6 on another display to the side. And it drives me mad, because when you have 2, you never know what's the right answer. You know, You get, if you, yeah, I mean, you basically have to, so basically when you have two, you just go through. What normally happens is one of them will be a little bit garbage, and then you'll get enough in the second one to understand the call sign. Now, the other thing that M1 does is it checks the call sign for you to say, does it look like a valid call sign? And it pops it in here. Right, so, but you get a load of garbage in here. This is just about unusable. You know, anything that looks like a call sign for it, it says it's a call sign. So basically, you can run two times. If you want to run Ritty as well, I bet this don't work. This is where I fail. Oh, there we go.
Oh, yes, there's
So basically, let's get rid of
one again.
that one. Basically, you have three windows, and they should all read the same. So when you get really expert, right, let me just quickly show you what the. Sorry. It's.
Well, one thing I find about using that, I mean, you've got quite a few different options on the screen there that you've gone through, obviously, as part of the presentation. But once you've standardised on whatever you're using and you get used to it, I find it's quite a relaxing contest because you can have a drink in one hand, a mouse in the other, your foot on the desk, and you're working them like fish in a barrel.
Yeah. I mean, I do it if it's a bit slow. I'm reading a book or web browsing on my laptop, other laptop. So this is the German station. You know the weather station. When you forget these two columns because I've taken these out of the log. This is from I think last night. What you'll see is basically the calling of it. So why is it said in RY?
Because it tests 2 and 4 and 1, 3 and 5 the holes to exercise all of the pins on the original readers.
Correct. And also when you're tuning it, it's equal number dots and marks and spaces. So in the good old days when you had a little lights, one for a mark, one for a space, well they weren't lights, whether they were some sort of cathode tube, you could get the same brightness on both, you knew you were tuned in. So this is what it calls CQ. These are the frequencies. Like I said, this one works. For me, it's been working really well lately. 4583. Yeah. And then let me just find where. So you do get. Is that a weather forecast? You do get some weather forecasts. Is that it? I couldn't actually find what I was looking for last night because I didn't have any of the ship ones. So you get these. This are the various seas and wave heights. You do. I was trying to find. So forget this. This is what you'll see as a line coming through if you don't have the synop ticked in FLDigi. You'll see this low digital figures, right? What FLDigi does for you, it decodes it. So what it does is it says this is the weather station associated with, I think, that number. It tells you then visibility, cloud height, wind speed, wind direction. The Fairford one comes up occasionally. If you're on at the right time, you can see Fairford. And the interesting ones are some of the ship ones because a lot of the ships have automatic weather stations on them now. I think they're sent back over the internet, but they give you wave heights and that in the middle of the Atlantic, in the middle of the Pacific. So, you might find those interesting. Right, that's all I was going to talk about. Thank you for listening. Is there any questions? So I hope you all have a go now.
Yeah, thanks for that, Viv. Really interesting. Answered my questions about the macros.
The other thing to mention is YouTube has got good videos on all this. So if you go to YouTube, the how to do it, and if you're really stuck, FLDigi has a 323-page manual, so you can read that.
That was the bit that put me off.